Thank you everyone for joining today's session. Today's topic is about Huawei solar inverters power control options. We will speak in detail about this. I hope you all are keeping safe and well at your homes or your offices. Uh, this is a topic of interest for many of the people because a lot of areas in the world are still off grid, and if they have grid, such areas do not allow to do net metering. So what options do you have in order to control not to let the power go into the grid? So there are many different ways of controlling that. So the grid tie point power export control options, you need multiple devices. The basic one is the inverter itself. In regard to the inverter, you will also need a smart logger or a dongle of Huawei. So these are the two optional items, but depending on the project scenarios, you might have different scenarios, different combinations of inverter. In the next slides, we'll go through in detail about different scenarios, different type of projects that you might have, and what type of control options you have when you have such different type of inverters. Application scenario description of power export control. But with a single phase inverter, you will take only 2 seconds from the point where the control is required. Let's suppose the power is going towards the grid and you want to control it from the point the power meter reads that, oh, there is a power extra going towards the grid. You need to control that till the time that the inverter receives and control. The whole process takes around 2 seconds. I'll have another slide in next where I will show you exactly in terms of a graph that how the inverter responds. When you are using multiple inverters with a smart dongle, these closed loop control will be 5 seconds. When you have multiple inverters with a smart logger, then you have 2 seconds. The closed loop control devices differ case to case. In a single phase, single inverter case, it is only the inverter itself. Yeah, so there are still limitations in that. We will speak in detail. Multiple inverter, you might have up to 10 inverters and in a project. You may have an option of using a smart dongle in that project and to do the power export control. Similarly, with the multiple inverters, you might use a smart logger when the case is less than 10 inverters or beyond a 10 inverter case. So in such cases, you have an option of using a smart logger to be the point of closed loop control. There are certain power meters that are listed in Huawei smart logger manual. If you do not find it, we can give you separately as an Excel sheet or a PDF format, which encloses all the power meters that you can use to do the zero export control. Now, these power meters must have some specifications. Let's say that a fresh delay that should be less than 0.25 seconds, and the slumping accuracy should be less than 1%. Communication should be in Modbus RTU protocol, which is one of the basic requirements for any power meter to communicate with the Huawei smart logger. In Huawei smart logger manual, you will find this list of power meters, and within those power meters, few of them would be having the feature to be used for the zero export control. Many of them are just used for reading the data, but cannot be used for the zero export. But yeah, there are a few of them which you can use for the zero export. That list is for the third-party power meters, but Huawei has also a power meter, which is DDSU, the single phase meter, and the DTSU, which is the three-phase meter. Now, with the single phase, normally you would be needing it for the residential spaces where you are using our 2 to 5 kilowatt inverter. You still need a zero export control, so that is an option to use. With the three-phase inverter, you have an option of using one or more inverter. Can be a small residential, can be a small commercial to medium-sized commercial project up to 170 kilowatt. You can use our DTSU power meter, which comes with CTs inside the power meter package. Apart from that, as I said, there is third-party meters listed with Huawei, and which is already in the Huawei smart logger library as well. So yeah, so there are different cases, as I said, with the single phase, single inverter. You have an option. With the multiple inverter, you can use our dongles, which are the WLAN and the 4G. Either of them you can use, but you need to know which one is compatible. And with the multiple inverters, you have an option of using smart logger, which you can control up to 80 inverters. And the supported inverter models, we have options of controlling all our low voltage inverters, starting from the two-phase to 2 kilowatt single phase, and the 100 kilowatt three-phase low voltage inverter. And the application which you will be using to do all these configurations will be the Fusion Solder, which is available for mobile as well, and also as a web browser. So we go with the first case of the single phase inverter power export control. I would like to give you a quick brief of the slide. In the next slide, you will see similar configurations of the power meter connected in the system where there is the inverter and the grid. So what will you do is that you will have a current transformer which will be reading the current data on the grid side, and there will be voltage lines connected to the inside the AC combiner, which will also go to your power meter. These power meter will read the voltage and current, and will understand what exactly power is flowing in which direction. When it goes towards the grid, it will understand that, oh, there is excess power which might need control. So depending on your control option, the logic inside the inverter will work and do the necessary control. So in the single phase inverter, you can have a smart power sensor which can be directly connected to the inverter. And you have an option of you using the dongle if you need the online monitoring. In some cases, we have seen where people do not require having a monitoring option. So you can do these setup without even a dongle as well. We have a three-phase option. With the three-phase again, we use the CTs to measure the current on the grid side, and direct lines to the AC combiner to read the voltage. And these meter again sends the data to the master inverter in the daisy chain, so that it gives the information to the dongle, and the dongle sends data to all the inverters for the necessary control. So again, we have option of using the DTSU, which is a Huawei power meter, and these Huawei power meter can be used up to a maximum of 170 kilowatt PV system. Larger than that size of a PV system, you will be having the need of looking at one of those Huawei whitelisted power meter list. Now you have an option of doing multiple inverters power export control with dongle. And there is another case where you use a smart logger. So when you're using the dongle, you make sure that you have multiple inverter, and at least there is one inverter which is compatible with that specific dongle type. Like let's say when you are speaking of the WLAN, as you might know that the WLAN is compatible from 3 to 20 kilowatt sizes, and the 4G is compatible from 3 to 100 kilowatt size inverters, excluding the only 36 kilowatt, which is one of our old type inverters. So in such scenarios, you will connect the smart power sensor directly to our inverter and do the configuration for the zero export control. Again, in this scenario, that the limitation applies on our Huawei power sensor to be used up to 170 kilowatt PV system. And above this size, the size of a PV system, you should look into one of those power meters that are recommended by Huawei from that party. Multiple inverter power export control scenario with a smart logger. Now, when you are having a smart logger in your system and you have multiple inverters, in that scenario, the connection of the smart power sensor or the power meter of the third party happens to be with the smart logger, and then smart logger reads the data from the power meter, applies the logic, and then sends the command to the inverters to have the necessary control done as per your active power control that you will be requiring, which we will be speaking in detail. Smart power sensor auto detection in Fusion Solar app. So when you are commissioning your PV system, the first phase is to detect the devices and commission your PV system. The first thing is to detect, and when you would be putting one of the devices which is in your PV system, the serial number of that device, and that PV system, all the related other inverters, devices that are connected, which are from Huawei, will be automatically detected. So that is one way. The other way around is that you manually detect the smart power sensor. So for that, what you will do is that you will have in the menu option, you will have, and you will go under maintenance. Under maintenance, you will be having the tab of 8 for delete device. So you will be clicking on that. You will have the battery or the power meter. You will select the power meter and select the smart power sensor being used by Huawei. So if there is a power meter connected, it will be automated and detected. This is the second method of connecting a power sensor if it is not getting detected automatically. Normally, the auto detection works fine. Power export control setting in Fusion Solar app. So now we will be going to speak about the main topic of the day, which is the export control. So with the power adjustment option that you will see in the Fusion Solar app, you will click that. You will have multiple options now for the power adjustment. The active power control, the reactive power control, and the grid tie point control. So we will be speaking about active power control as a whole, but grid tie point control is itself a type of active power control. So we will be now speaking of the different options that you will have about grid tie point control. You will click that option. A small window will pop up on your screen, telling you to put the password, so that to authenticate whether the right person is doing the necessary changes for the controls or not. So the default password that you will have is the 5 times 0A. You will put that, and then you will enter, and then you will go to the active power. Under the active power, you will have the control mode. Now you have multiple control modes, which we will be speaking now in detail. The power control mode under the grid tie point is the unlimited mode, grid connection with zero power, and power limited grid connection. So just to give you again basic understanding of these type of control is that it actually looks the power being fed from the grid tie point. So what is the grid tie point? Grid tie point in your PV system is actually an AC combiner or LV panel of your house or your facility, where the power from the grid and from your PV system comes and accumulates. Either it goes towards the load, it goes towards the grid. That point is actually grid tie point, or in POC, which you call is the power point of connection in your PV system. So in that scenario, you will be using a power meter to read constantly and the direction of flow of power and the amount of power that is being fed in each of the direction to do the control. In the active power control, you also have an option of not looking at that grid tie point and also directly do control, such as you limit your inverter of a 50 kilowatt to a 25 kilowatt, so that it doesn't give power more than a 25 kilowatt. Then such type of control doesn't require that you have a power meter installed at your point of connection, constantly monitoring and feeding the data towards your inverter, because you have limited your inverter, which has to read the generation of your PV side, and then it has to control. If it is below the 25 kilowatt, it doesn't require a curtailment of your PV system. If it requires, then it will be done by the inverter without the need of a power meter in that case. So we will speak in both scenarios. Right now, the scenario that we have these three options: the unlimited mode, the grid connection with zero power, and the power limit grid connection. These are three options are type of a monitoring from the grid type point control. Zero export control closed loop controller. So the, you must select the type of closed loop control that you will be having in your PV system, because the system is not as intelligent as you are. So you have to tell exactly the system whether the control will happen with the inverter or from the smart logger or dongle. So if you have more than one inverter, you will be choosing the smart dongle, smart logger option under the closed loop control. Otherwise, if you have a single inverter, your PV system, then the closed loop control, you will select the device, the inverter. Zero export control setting with the single phase. If you have a single phase inverter, which is the 2, 3, 4, 5 kilowatt of the Huawei, the Sun 2000L series, so you can do the zero export control. And in such scenario, if the power being, let's say, generated is 3 kilowatt and the load is 3 kilowatt as well, so all the power will be fed to the load. Let's take the case where the generation is 4 kilowatt from these inverter, and the load is requiring only 3 kilowatt as shown. Then what happens is that since the generation capacity is more than 3 kilowatt, which is the requirement of the load, the inverter will curtail power immediately to 3 kilowatt, and thus the output power will be limited to 3 kilowatt, which is exactly the load requirement, and zero power will be fed towards the grid side. In a case where the power requirement of the load side is more than what is the generation capacity of your inverters, in that case the excess power required will be taken from the grid side. So these two pictures shown in this slide is a quick description of how this system works when you are having a single phase scenario and you are doing the zero export control. Zero export control setting with the total power limit. Now you have a three-phase PV system, and then you are doing a zero export control. In this scenario, what you will do is that you will have the total power option, or you have option of the single phase power. In the single phase power, what happens is that the power that is having the phase that is having the maximum power, the meter or the system will not allow that there should be any excess generation going toward the grid side on that phase. It will be explained in the next phase, but this slide is specifically from the total power limit option. When you are having these option in your PV system, what does it do is that it sums the power of all the load side. Let's take the example on this screen. Where on the first phase the load is 1 kilowatt, the second phase there is 2 kilowatt, the third phase there is 3 kilowatt. Okay, so what happens is that, and if you sum all these three, and the generation will be limited. Let's suppose this is this inverter has a capacity of generating 8 kilowatt right at this moment. It will be limited to 6 kilowatt, which is equivalent to the sum of all these three loads. So since the inverter cannot give variable output, so what happens is that it will provide distribute the 6 kilowatt to each phase, 2, 2, 2. In the first phase, there will be 1 kilowatt going towards the grid. In the second phase, there would be zero power going or coming from the grid because it matches to the load requirement. In the third phase, it is 3 kilowatt load, and the generation is only 2 kilowatts, so 1 kilowatt will be taken from the grid. But if you sum the power going towards the grid and the power coming from the grid side is actually zero. This is the type of control if you need, you can do, and for that under the unlimited mode you will have to select the total power. The zero export control setting with the single phase limit. Now under the unlimited mode you will have the single phase power option, What it does is that if you select the single phase power option, so no backfeeding will occur for the phase with the maximum power. So let's suppose you have here in this scenario, you have a 3 kilowatt. This is and if the generation is on all the three phases are, let's suppose 4 kilowatts. So it will be limiting, the inverter will be limiting itself based on the phase which has the highest generation. And on these phases there will be no backfeeding occurring, but maybe on the other two phases where the load is less, there might be a backfeeding occurring. So this is another type of control option that you have. Response time setting of zero export. As I said earlier, I have a slide, so this is the one. Uh, there is three lines as shown here. The blue line is the exported power, the red one is the inverter output power, and the light green one is the load power. So if you see here, normally when you have a zero export control option, not based on the total power or the single phase power, rather you have an option of also the zero export completely, where no power goes to any from the any phase towards the grid. That is also an option in our inverter. So in that scenario, the exported power, the blue line, is always zero. At some point, when the one of the loads goes down, which is the light green, at this point goes down, for a very short instance, there will be some power exported towards the grid till the inverter detects that there is excess generation going towards the grid, and it reacts against that. That whole period takes around 2 seconds. When this is the case true for the single phase and the multiple inverter with the smart motor. And again, after some time, yeah, after 2 seconds, it will again come to the point where it will be giving zero power toward the grid side. It may go below zero and take a little for a very short moment, but again it will get itself stable within 2 seconds. Now you have the second option. The second option is power limited grid connection. We spoke of the zero export. Now you have an option of limiting your inverter output. Grid type point limit. If you are selecting this option under the control mode of power limited with grid connected, you have multiple options. One way is to limit the output of your inverter based on the kilowatt capacity, and the other way around is that you put a percentage of the maximum power that your inverter can generate. Let's suppose in this scenario, which we have a slide on, the inverter capacity is limited to only 5 kilowatt. So the inverter will only give 5 kilowatt. If the inverter has even 15 or 20 or 30 kilowatt generation capacity, since you have limited the output power of this inverter to 5 kilowatt, it will be only giving an output of 5 kilowatt. So what happens is that in that case, whatever the load is, uh, 5 kilowatt may go towards the grid if the towards the load if it requires. Otherwise, any extra generation will be going towards the grid side. I missed one of the slides. Okay. Inverter output power adjustment. This function is used to open loop to adjust the output active and reactive power of the inverter. Since we are speaking about the active power in this presentation, so this will again proceed with the active power control. So again, under the power adjustment, you have the second option of the active power control. In these, you will have again multiple options. And you can limit now the output power of the inverter based on the percentage as well, as I said. Let's take this simple case where we have an inverter of 6 kilowatt, the 6 KTL-M0, which is a three-phase Huawei inverter. And if you are connecting an 8 kilowatt peak, the generation can go more than 6 kilowatt in some point of time if the weather conditions are very good. So with the maximum power output of these inverter, which is 6.6 kilowatt, all Huawei inverters have a generation capacity of 10% extra than the rated power. So a 6 kilowatt can provide you up to a 6.6 kilowatt up till a certain temperature. So if you're limiting it to 50%, so 50% of 6.6 is 3.3 kilowatt. So whatever the generation is, it if it is more than 3.3, it will be limited to 3.3. If it is below 3.3, then it will be not, the power will not be cut. So you can have an option of curtailing the output power of your inverter with the percentage. So such option is available under the active power control option. Uh, Inverter active power control in fixed value. We discussed it a while ago as well. If you have a 6 kilowatt inverter, you want to limit it to a 3 kilowatt, you have an option of that, and it will give you a maximum power of 3 kilowatt, not more than that. So in some scenarios, you might be required to do so, but in most of the cases, the option that you will be needing mostly is the zero export control. So that is very simple. You have an option of under the grid type 1 control where you can select the zero export control for the 3 phase. So thank you very much, guys. My slides are finished. If you have any particular question, please write down in the chat section and I will be answering them.